Hi, folks. So I'm going to talk a little bit now about scales and then how we put this all together. So when I'm saying another thing to think about is the type of data scale that you have that you're working with, or sometimes in cartography we call these levels of measurement. So I'm going to talk about those levels of measurement. Um, but there are some other scales or ways of describing this than the ones we normally talk about. The ones I normally talk about in relationship to cartographic representation are nominal, ordinal, interval, and ratio scales. Um, but there are other scales too. So, you might think about some other types of scales. Um, so you want to watch out when you're doing your data visualization that you are using the correct scale, because the scale that you use um, can really impact what you are representing, right? Um, like if you have a pie chart, if you actually want to represent accurately, um, then you have to use you can't just put the numbers in and divide it into quarters and then put the numbers in, right? You have to actually divide the pie chart according to the numbers. And then the other thing is the linear versus logarithmic scale. So on a linear scale here, we have number of millions of people starting from like zero to down, and this is states, right? How many people are in each state, and we're comparing it between a linear graph where it shows it on a linear line scale versus a logarithmic scale. So on a linear scale, um, you can see you can see the scale is evenly divided between 0 and 50 million people. Um, and you can see that there are a lot of states that have less than 10 million people, but it's very hard to see their distribution on that linear scale. So in some cases, you might change and transform your data into a logarithmic scale, which allows you to spread out the numbers, right? So then we're seeing the numbers between 0 and 10 million are spread out across most of the chart, so that you can really see the difference in the number of states that have less than 1 million versus the number of states that have between like 2 and 5 million, right? So sometimes it's helpful to change scales, okay? Um, but so I want to talk again and review. Hopefully this is familiar to you, but if it's not, I'm going to take a minute to go over it. So some of the most commonly used scales or ways of thinking about scales are nominal, ordinal, interval, and ratio scales. So a nominal type of data or scale would be um, a categorical type of data, categorical or nominal type of data. That's the same thing. So if you have, for example, different species of trees, that would be categorical data, right? If you have different genders, that would be categorical data. Um, if you have, I'm trying to think of another example. We've got some on the screen here. Colors, different colors of things. That would be categorical data. It's a data that is essentially qualitative. There's no ranking or order, but things are just classified into groups. Okay, categorical data requires certain types of mapping, and is only appropriate for certain types of charts or graphs. So, for example, a bar chart, you can chart categorical data. Ordinal data is an ordered list. Okay, so it's not exactly numbers, but it's not exactly just categories, because you're ordering the list from best to worst, or from most drained to least drained, or very damp soil to very dry soil. So there's some kind of order to this list of things, but it's not really necessarily numerical data. In our example here on the screen, we have tree cover, and somebody has estimated low, medium, and high tree cover for this area. So when you get into ordinal data, for example, on a map, this is where you might think about representing things in terms of its saturation. So rather than categorical data, you might just pick different hues, different colors to represent different categories, right? Or different shapes to represent different categories. But with ordinal data, you want to give some sense that there is more or less of a certain characteristic, right? And so, for example, you might have the trees be a darker shade, more saturated shade of green if it's a high tree area, and a less saturated shade of green if it's a low tree cover area. So that's ordinal data. Then we have interval data. Interval data is some kind of number, and the difference between the numbers is significant. Okay, so temperature is in Celsius is an example of interval data. It's something that you could graph on a number line. It has an arbitrary zero, and it can have negative values. The measurements always have a unit. So temperature in Celsius, you can have below zero temperatures like we are having right now while I'm filming this video. So it's an actual number. It's not just a ranking system, but it has no necessarily firm zero to it, and it can have negative values, and it has some kind of measurement unit that you're measuring in. And then the sort of highest order type of this data that you can have is ratio data. So ratio data is numerical. It has the difference between the numbers is significant, and it has an actual zero, right? So, for example, percentage data has a zero, and you can't have negative percent of something, right? You can't have negative percent tree cover. You could have negative growth. There's some certain things that you might be able to say that you could have negative percent data, but in general, non-arbitrary zero. And this is the kind of data that you can actually do arithmetic on. So it can be divided, it can be rescaled, and it conveys more information. Okay. So examples of this are the cost or price of something, ages, the finish times for races, right? If we go back here, ordinal data would be who finished first, second, and third in a race. Okay. We don't know their times. We don't know anything more about how they ran the race. We just know who finished first, second, and third. That's a ranking system. Compared to ratio data, which would be, we wanted to have the actual times. How long did it take each person to run the race? that is a higher level, a different scale of information. Um, and yeah, so I'm going to go over more on this. This calls for different types of mapping. Okay. Um, so if you have numerical data like um, interval or ratio data, you can do different types of mapping with that compared to ordinal or categorical um, data. Another scale that you might think about is cyclical data, such as time, right? Time goes around and around instead of on a linear. I mean, we might think of time as linear in a way, but there are these cycles within time, daily, weekly, monthly, the seasons, right? Yearly. And so that might require a different type of charting and graphing than data that is linear in some sense. So now, I'm just real quickly, you can put together some of these variables that we have been talking about and to create different types of graphs and charts or different types of maps, right? So, like in this example here, we've got 3 different types of coordinate systems and then 3 different ways of showing your variables, 3 different visual cues, right? So you've got a Cartesian coordinate system, and from that you can make a scatter plot. If you're using position, you can use length and make a bar chart. You can use angle and make some kind of pie chart, right? Um, if you have polar, um, a polar coordinate system, you can make these sort of round charts. The one on the left looks like a bullseye, right? Where you're saying the positions relative to this round bullseye, right? You could make something where the length related to its position on the circle. So this is a classic example of this is if each of those little bars was a month of the year, you could show how frequent some, maybe a sickness happened more during one month of the year, but you were showing it over multiple years, and so you're showing it as a cycle rather than just a random line, random bar chart, right? Polar and angle, obviously pie chart. And then down here we've got geographic. So position is the first one. And then the second one there, you can show length of lines between places. Or and you can actually put a pie chart onto a geographic map. It You can do it. It's a little bit complex, and so maybe you might want to think about whether that is actually a good data visualization to do, but you could. So here we have some coordinate systems and direction, shapes, areas or volumes, and color, and the different kinds of charts you can make with those. So direction, you could make a line graph. You could make a like I just keep on thinking of these polar charts as having to do with time, right? But you could actually be making a polar map, right? So you could have direction shown with a line and showing which direction on a map the wind was blowing, for example. You can add shapes onto your map, onto your chart. You can use graduated symbols to show area or volume. And um, you can use color to in your graphs to indicate another variable potentially in your chart, or to emphasize a certain variable, right? This is chloropleth maps, um, or unique value maps. Both use color to indicate some variable on the map. All right, so now we've kind of put it all together. We've got some examples of some different kinds of graphs or charts. If you also read some of the readings, they have some different examples to help you pick out what kinds of graphs and charts you might want to make. All right, thanks. I will see you later.